Hello viewers, my name is Deepti Mukherjee and today's topic is operations on real numbers. Operations means mathematical operations, and mathematical operations are addition, subtraction, multiplication, division. And real numbers are rational and irrational. Today I will discuss about the mathematical operations of two rational numbers, two irrational numbers, and one rational and one irrational number. So, at first, two rational numbers. Addition, like two rational number, that is 1 by 2 plus 3 by 2 is equal to 4 by 2 is equal to 2. That means it is also rational. Now subtraction here 1 by 2 minus 3 by 2, here minus 1 is also rational number, so subtraction of two rational numbers are also rational number. Now multiplication, multiply 1 by 2 into 3 by 2, then we get 3 by 4, which is also rational number. So multiplication of two rational numbers are also rational numbers. Now division, 1 by 2 by 3 by 2, then 1 by 3. 1 by 3 is also rational number, so the division of two rational numbers are also rational numbers. Now irrational numbers. For irrational numbers, addition, two irrational numbers like root 2 plus root 3. Here root 2 and root 3 both are non-terminating in decimal expansion, and that is irrational numbers, so the addition is also irrational number. And now subtraction, root 2 minus root 2, that is 0. So not every time it is irrational number. So when we subtract two irrational numbers, then that may be rational number. Sometimes it is irrational number, sometimes it is rational number. Now multiplication, root 2 into root 2 is equal to, or root 3 into root 3 is equal to rational number. So it is also not applicable for a multiplication, that two irrational numbers after multiplication is irrational number. It is sometimes irrational, sometimes rational. Now division, root 5 by root 5 is equal to 1, what is also rational number. So sometimes two irrational numbers, when we divide two irrational numbers, it is sometimes rational number, but sometimes irrational number. Now the third point, that is one is rational, another is irrational. Addition, for addition 2 plus root 3, here 2 is rational, root 3 is irrational, and after addition we get irrational numbers, because root 3 is non-terminating decimal expansion, so we get 2 plus root 3 is also irrational number. Now 2 minus root 3, here also we get irrational number. In subtraction, multiplication 2 into root 3, that is also irrational number, and division 2 by root 3, here we get irrational number. So when we add, subtract or multiply or divide one rational, another irrational, then we get irrational numbers. Now I am going to discuss about some problems of NCERT book exercise 1.5. Question number 1. Classify the following numbers as rational or irrational. First, 2 minus root 5. 2 minus root 5 is, that is, one is rational, another is irrational, and I have explained that when we add, subtract, multiply or divide one rational and another irrational, then we get irrational number. Here 2 minus root 5 we get irrational number, and we can check if we get non-terminating decimal expansion, then we can say that is irrational number, and here 2 minus root 5 we get the irrational number. Now second, 3 plus square root of 23 minus square root of 23. Here we get 3. 3 is rational number, so the answer is rational number, because plus square root 23 and minus square root 23 cancel, one square root 23 and square root plus minus cancel, and so it is only 3. Now third, 2 root 7 square root 7 by 7 square root 7. Here square root 7 and square root 7 cancelled, so 2 by 7 answer. 2 by 7 is rational number, so it is rational number. Now 4, 1 by root 2. 1 by root 2 is irrational number. Now 2 pi. Pi is irrational, so 2 pi is also irrational number. Now question number 2. Simplify each of the following expression. 3 plus root 3, 2 plus root 2. Here we can multiply like this. 3 plus root 3 and 2 plus root 2. Then 3 into 2, 3 into root 2. And now root 3 into 2 and root 3 into root 2. Then we get 3 into 2, 6 plus 3 into root 2. And then we get 2 root 3 and plus root 6. That is the answer. Now next, 3 plus root 3 square root 3 into 3 minus square root 3. Here we get, we know that a plus b into a minus b is equal to a square minus b square. So we get 3 square minus root 3 square, that is 3 square is 9 and root 3 square is 3, so 6. Now question number 3. Root 5 plus root 2 whole square. Root 5 plus root 2 whole square, we know a plus b whole square is equal to a square plus 2ab plus b square. Then we get a square is root 5 square is equal to 5, b and 2ab is equal to 2 root 10, and b square is equal to root 2 square is 2. So the answer is 5 plus 2 root 10 plus 2. Now root 5 minus root 2 into root 5 plus root 2. Here also we can multiply and that rule, that is a minus b and a plus b, a square minus b square. So we get a square is equal to root 5 square, that is 5 minus root 2 square is equal to 2. So we get 5 minus 2 is equal to 3. Now question number 3. Recall pi is defined as a ratio of the circumference, say C, of a circle to its diameter, say D, that is pi is equal to C by D. This seems to contradict the fact that pi is irrational. Now will you resolve this contradiction? Pi is equal to C by D and pi is equal to 2 pi r by D. Here we use pi as in decimal point sum, not as non-terminating. We get some points of it and then we not get that is in irrational number. So there is no contradiction. Approximate rational value, that either C or D is irrational. Okay, now represent root 9.3 on the number line. 9.3 on number line. Okay, I am showing it. Here I draw a line 9.3 centimeter. 9.3 centimeter. Now extend it 1 centimeter. Now divide this line into 2 equal parts and then join this. I divide this line into 2 equal parts. Now this point is the center and I draw a half circle from here. This is half circle and that point where it was 1 centimeter, from that point I join on the circumference of that semicircle, and this portion is square root 9.3 and I draw here 9.3 in this way, and this portion is point 9.3 and here this is on number line. And we calculate it from Pythagoras theorem, because Pythagoras theorem we know it can be calculated easily. Question number 5. Rationalize the denominators of the following. 1 by root 7. For rationalize, we multiply in a numerator and denominator by root 7, then we get 1 by root 7 into root 7 by root 7, so root 7 by 7. That is answer. Now for the second is 1 by root 7 minus root 6. Here we multiply root 7 plus root 6 by root 7 plus root 6, and then we get a square minus b square. 7 minus 6 is 1, and root 7 plus root 6. 1 by root 5 plus 2. Here we multiply numerator and denominator by root 5 minus root 2. Then we get root 5 minus root 2 by by 3. And now 1 by square root 7 minus 2. Square root 7 plus 2. Square root 7 plus 2. We multiply in numerator and denominator. Then we get 7 plus root 2 by 7 plus 2, root 7 plus 2 by root 7 square 7 minus 4, that is 3. So we get root 7 minus 2 is equal to root 7 plus 2 by 3. Root 7 plus 2 by 3. Thank you.